Okay, but what even is AWS? It's fundamentally a way to rent compute at varying levels of abstraction. That's it. Thanks for watching. Okay, but more seriously, there's a reason why I've been able to create so many videos about AWS without running out of topics. AWS is a huge topic, with 200 plus services and countless certifications, conferences, and courses dedicated to helping us understand it. This is going to be a very succinct intro into what are, in my opinion, the most essential AWS services. Let's start with establishing the mental model of AWS that I use. You can think of AWS services as existing on an abstraction ladder. The closer to the ground you are, the closer you are to the actual virtual machines and servers. The higher up you go, the more abstracted and costly everything gets. Let's start at the bottom. Okay, starting with EC2. EC2 stands for Elastic Compute Cloud. It's a virtual machine in AWS's data center, and basically as close as you can get to bare metal on AWS. You choose CPU, RAM, storage, network, and the OS when you're spinning up the instance. And then all AWS does for you is send you a bill. Software installation, security patches, backups, and scaling are all your problem. EC2 is billed by the second, and you can stop your instances at any time. Just make sure your data is in an EBS store, or otherwise it might get deleted forever. Speaking of storage, let's talk about S3. S3, or Simple Storage Service, stores files forever. It has 11 nines of durability. That means if you had 1 million files in S3, you'd only lose one of them every 100,000 years. They do this by copying your files across multiple servers and multiple data centers, all before returning a 200 status code. It's automatically saved extremely quickly and is available to get requests at any time, which also resolves extremely quickly. This means that S3 is not a file system. You have to upload and download full complete files, and you can't edit them in place. S3 and other S3 compatible storage systems like Cloudflare R2 are the backbone of the modern internet, and AWS knows it. S3 costs 2 cents per gigabyte per month for storage, and 9 cents per gigabyte per month to transfer it out to the internet. SQS, or Simple Queue Service, is the last of AWS's original 3 services from its launch in 2006, along with EC2 and S3. SQS is a message queue. Service A puts messages in, Service B pulls them out. If Service B crashes while processing a message, that message automatically goes back into the queue and is retried. Queues are extremely useful for decoupling your services. If Service B is down, without a queue, Service A would also go down. SQS makes 2 promises. Messages don't get lost, and they're delivered at least once, unless you turn on some special settings. SQS pricing is basically free. 1 million messages costs a fraction of a cent. SNS, or Simple Notification Service, broadcasts messages to multiple subscribers. The main difference between SQS and SNS is that SNS is focused on delivering messages to multiple subscribers, which can even include text messages. Let's use the example of a monitoring service. You create an SNS topic and publish an error message to that topic. This single message can trigger multiple subscribers, which, for example, can call a Lambda function to update your status page, send a text message to your team, and create a message in an SQS queue simultaneously. The critical thing about SNS is one message can go to multiple subscribers. Like SQS, pricing is essentially free for normal usage. The next service, Fargate, is a pretty far jump up the abstraction ladder. Fargate runs your Docker containers without you having to manage servers. Normally with containers, you need servers to run them on. You manage those servers, patch them, and scale them. Fargate deals with all of that automatically. You give AWS your container and specify CPU and memory, and Fargate deals with the rest. It's different from EC2 because you're not managing a full virtual machine, and it's different from Lambda because it supports stateful containers. Fargate can run basically any type of Docker container, and it can even auto-scale them too using ECS. You pay per second for your configured CPU and memory, even if it's not being used. The higher level of abstraction from EC2 costs you about a 30% premium. Okay, and another huge jump up the abstraction ladder is RDS. RDS runs Postgres, MySQL, and other relational databases, but AWS manages all of the operational parts. They manage the daily backups, software patches, automatic failover, and point-in-time recovery. All you have to do is manage the schema, queries, and indexes. This means that AWS abstracts away all of the CPU cores, memory, and storage, and just gives you a SQL connection. RDS costs about 30% more than running the same database yourself on EC2. Note that RDS is still one database server, and maybe with a standby. Scaling RDS means a beefier server, not multiple servers. Lambdas are basically as abstracted away as you can get on AWS. All you care about is your code. AWS manages auto-scaling the functions from 0 to essentially infinite, and scaling them down to 0 when you're not using them either. You pay per invocation and by the second of usage. Lambdas can be written in an officially supported runtime like Node.js or Python, Or you can deploy a binary that communicates with the Lambda HTTP API, like Rust. The only constraints on Lambdas are a 15-minute max runtime, 10 gigs of maximum memory, and that they're completely stateless. This means that Lambdas are perfect for event-driven work and stateless APIs that just talk to a database. They can fire when an S3 upload occurs, run a cron job every 5 minutes, respond to an API request, and so much more very, very easily. However, Lambdas are much more expensive than EC2 or even Fargate if you have consistent workloads. The power of Lambda is paying for exactly what you use when you're using them, and they're great if you don't really know your usage patterns yet, or you just don't want to think about scaling. That is, in my opinion, the most important services in AWS. The abstraction ladder is a great way to think about AWS because you can understand the trade-offs of abstraction. When you're a small and scrappy startup, the increased cost of these more managed services is almost always worth the reduced complexity they bring. And if you have problems after scaling, come talk to us. We help companies from mid-sized startups to huge unicorns reduce their cloud bill by up to 60%. I'm planning on doing longer form deep dives into all of these services, including how Pump can save you a ton of money on running them. With all that being said, please like and subscribe and comment which service you want me to cover first.